Example 1 says for the given functions f and g, find the following and state the domain of each result. So here's my f of x function. We have 3x minus 5, and here's my g of x function, 4 minus x. So in part A, I need to find f plus g of x. So if we expand that out, that is f of x plus g of x. So substitute in your values here. Or not really values, but substitute in your functions, right? What is my f of x function? That is 3x minus 5. Plus, what's my g of x function? 4 minus x. Okay, so now combine your like terms. 3 minus 1 gives me 2, so 2x. Negative 5 plus 4 gives me a negative 1. Okay, so that is my f plus g of x. So when I add these two functions together, I get a whole new function right here. So now what happens when I subtract these functions? So f minus g of x, when I expand that out, is f of x minus g of x. Okay, you need to make a note somewhere, somehow, that when we subtract, we are going to subtract that entire thing. So that needs to go in parentheses when we substitute that in. So f of x is still 3x minus 5, and then minus the entire function of 4 minus x. Okay, if you don't include those parentheses, the only thing you'd be subtracting is this 4, but I need to subtract the whole thing. And so now what's going to happen is I need to distribute that negative to everything in that second function. So we have 3x minus 5, negative times positive makes that a minus 4, and negative times negative makes that a positive x. So now when I combine like terms, we have 3x plus x to give me 4x, and negative 5 minus 4 gives me negative 9. So now when I subtract these two functions together, this is my new function. Make a note somewhere, star it, highlight it, something. When we subtract, that needs to go in parentheses. That's the biggest mistake with me. So now C is fg of x. And so sometimes you'll see that dot in between, but we know if two things are together, that operation is multiplication. So this is f of x times g of x. So my f of x is 3x minus 5. That's going in parentheses, and my g of x is 4 minus x. So when I multiply two binomials, we use FOIL. So my first is 3x times 4 to give me 12x. My outer, 3x times negative x, and that's going to give me a negative 3x squared. And so I'm going to put this over here. First, outer, inner, last. So when I do my first and outer, that's distributing this 3x to both terms in the second binomial. So then now my inner terms are right here. And that's going to give me a negative 20. And then my last terms, negative 5 times negative x, to give me a positive 5x. And so this inner and last, notice I'm taking that second term and I'm distributing it to both of those. So combine like terms, I have no other x squareds. So this is negative 3x squared. I do have two x terms. So 12 plus 5 gives me 17x. And then bring down that minus 20. So when I multiply these two functions together, which are both linear because they're both x to the first power, I now get an x squared. So we get a quadratic. It's a quadratic because of that x squared. Now, before we go over part D, I want to kind of rewind and go back up for a second. It tells me here to not just find the following, but also state the domain of each result. I've waited till the end because these all, let me zoom out a little bit. These all have the same domain right here. So all three of these, A, B, and C, have a domain of negative infinity to infinity, which is the same as saying that it is all real numbers. Okay, it's been a while since we've done domain from equations, so why? Why is the domain here all real numbers? Well, we have two mathematical commandments of domain. Thou shalt not divide by 0. I have no denominator, and specifically no variable in the denominator for any of those. So first, because we have no fractions. Okay, number 2, we also had thou shalt not take the square root or any even root of a negative number. Well, I don't have any square roots in my answer. Oops, so no radicals or no square roots. So when I have no fractions and when I have no square roots, my domain is going to always be all real numbers. I'm going to zoom back in, and now let's go over part D. Part D is f over g of x, which if we expand that out is f of x minus g of x. So f of x is 3x minus 5, and g of x is x minus 4. I cannot simplify anything. I cannot cancel out those x's. So this is my function. Now, it does not have the same domain as this one here. It is not all real numbers because this one has a fraction. So here, to find its domain, we have to make sure that this bottom portion, 4 minus x, does not equal 0. So you can do this one of two ways. You could subtract the 4 over and then divide by -1, but the easiest way here is just simply to add this x over. So I'm going to get 4 cannot equal x, which is the same as saying that x cannot equal 4. So I'm not sure if you need to write this in interval notation or set notation. Set notation, you're just typing in this. But if it's interval notation, then we are talking about every number that is less than 4. So negative infinity to 4, but with a parenthesis, so it doesn't include it. And then the union, now I need to talk about every number that's greater than 4. So 4 to infinity. I encourage you to try to do example 2 on your own. It is very, very close to what we just did here. So try doing example 2 and then hitting play and checking your answers.